Hi, my name is Marc-André Sirard from Canada, and I would like to welcome you to my virtual presentation that I'm going to make today. And I hope that wherever you are in the world, that your health is good and that were able to maintain our professional activities despite the historical and unique situation we're all facing in the world today. My task this morning is to challenge you with the perception that the role of LH, FSH, and HCG might be different than the one you think you have understood so far. So I'm going to challenge you to rethink about the importance and different role of those three gonadotropins in my presentation. Let's start with a difficult constatation. Ovarian stimulation does not work very well. In fact, compared to other medical procedures, the success is abnormally low, considering that we're simply emulating a natural process. I have been in this field since 1980, and I would have liked to believe that 40 years down the road, we would have been able today to replicate the last week of folliculogenesis with complete success. But I must face the reality, this is not the case. Take the number any way you want, less than 1 egg out of 10 ends up as a baby born. So we fail with the vast majority of oocytes, even considering uterine receptivity. Why oocyte quality is so low? In humans, as other mammals, we have different contexts. It seems that our species has developed a number of modifications to somewhat reduce fertility. First, by limiting the number of ovulation to 1 follicle per cycle, and then by limiting the fertility to a small window of our life, like from 15 years to 40 years of age. And secondly, by postponing puberty more than 10 years compared to large mammal. If you look at the mouse, puberty is attained at day 21, the pig 6 months, and the cow at 1 year. So in human, having to go over to 10 to 12 years is a real time that the ovary has to adapt, not producing ovulation during all that period. And we also believe that there's an intra-ovarian mechanism that exists to prevent uterine crowding in human. And so the ovary can sense if there's a problem and manage to reduce oocytes quality. And this has been observed in all mammals when we use external stimulation to create more ovulation than expected in that innate species. Now, I would like to continue my presentation with one fundamental question. Why animal and human makes 2 or 3 gonadotropin, considering that HCG and LH are chemically different and have different effects? The simplest answer, considering the natural selection process, is that those 2 gonadotropin must have different functions. And logically, if they do not have the same function, they should have different regulation. Otherwise, one would have prevailed and the other one would have disappeared. So I'm going to use this simplified graph to illustrate the change in FSH and LH levels in the menstrual cycle to highlight the dynamic process that takes on as a complementary of the 2 gonadotropin, how they complement each other, not necessarily work in combination, but work one after the other. So let's start with FSH. Here it's the line in blue. So the level of FSH goes up during the follicular phase until there's a dominant follicle. The appearance of the dominant follicle signal that you will be the one going the rest of the way towards ovulation. So the dominant follicle creates a drop in circulating FSH, preventing the other follicles to grow or to develop LH receptor. From that moment, the largest follicles can continue its development under the support of LH. If we look at the natural conditions, potential effect of decreasing FSH on the follicular development, I would like to point out that in non-stimulation cycle, there's a 5-day window where FSH is decreasing before the ovulation, and at the same time estradiol is rising. The importance of that decrease is not clear in human, But in my favorite animal model, the cow, it's been demonstrated that this decline contribution directly to the increased developmental competence of the oocytes. So the oocytes start to prepare for ovulation, not when LH arrives, when FSH starts to decrease. So that's a very important point for the rest of the talk. As for LH, the level remains quite low and initially support the androgen production. The LH release from the pituitary becomes sensitive to the amount of estradiol and start increasing in intensity and frequency as the triggering level gets closer. Once the follicle has reached the optimal level of differentiation, as demonstrated by the rise in estradiol, the pituitary makes the decision to ovulate and release a large amount of LH in a matter of a few hours to trigger ovulation. So LH has unique capacity that FSH doesn't have, especially at high level stimulation. So probably everybody in here is aware of what I just presented because it's normal physiology. What I would like to add as a granulosa cells genomic person that has studied the genes in the gene response to all kind of stimulation protocol in animals and in humans, I would like to focus on the fact that the cells have a different genomic response to the two different hormones. If I want to summarize the effect of thousands of genes, we could say that the FSH is mainly promoting growth of the follicle, including cell division, and estradiol is mainly and estradiol biosynthesis, and LH is mainly important for the differentiation process. And both hormones are working together or at the same kind of mechanism for steroid production, but they have, for other purposes, quite different gene targets. To summarize the change that may have to occur, you have to realize the granulosa cells, which is an epithelia, has to prepare to become a stroma that's going to form the corpus luteum. And normally, never an epithelia become a stromal cell in our body except for cancer. So it's a very different modification of cellular behavior that the drop of FSH and the increase of LH creates in these cells, preparing to become similar kind of liver cells. Indeed, they will have to, a bit as the liver has to do, transform a lot of fat, in that case, of cholesterol, into progesterone. And those cells become very metabolically active to be able to do that. Now, moving to the stimulated cycle, to prevent dominancy and the demise of smaller follicle, we use exogenous gonadotropin during a few days to try to recruit more follicle. But we do not mimic the decrease in FSH in the window of low FSH on the beginning of the trigger, and as we see in non-stimulated cycle. The final picture is that none of the common ovarian protocol used today has included an FSH decrease period to mimic the natural process. So normally, as seen here in a picture, FSH is maintained all the way until the LH surge to create all those follicles to become dominant and then to allow them to ovulate. But we're not mimicking any decrease here. This is why I would dare to suggest to investigate the importance of the natural dynamics of FSH and then LH. Of course, we would prefer having more than one dominant follicle, and therefore we need an FSH extension using exogenous injections, but how we can modulate the change in a time control fashion. I would like to propose a new paradigm where the differentiation of the follicle is a one-way street, and we can synchronize the beginning of differentiation that we want to have by creating a better synchrony and triggering all the follicles at the same time. I mean, that's normally what we do, but to have them all receptive at the same time, so they will all process or proceed with the right level of differentiation at from triggering to recovery of the oocytes in 34 hours. So the concept is reducing FSH support to send a signal to the growing follicle and to limit the recruiting of small ones, and such decrease should be done when a sufficient amount of follicles have reached 10 or 11 millimeter, so they do not depend on FSH anymore. Otherwise, they're gonna go into atresia. Replacing then the FSH support by LH or HCG, knowing that the half-life of the two products are different, as well as their function. So there's different option here that one might try to evaluate to try to replace the FSH with the LH for the end of the stimulation. LH could also be present from the beginning, but at the low dose, not to induce differentiation. As soon as the follicle has LH receptor, so 12 millimeter and more, the presence of LH will start the process of getting ready for ovulation. So you don't want to extend that period too long, because then the oocytes will demise or will decrease in quality. Does such treatment has been tried before? Yes and no. I'll present two examples of people that have started playing it with that, but there's not enough work, really not sufficient work, to really make a conclusion if the dynamic use of FSH and LH that would mimic the natural cycle is not a better solution compared to constant level of both hormones during stimulation. So let's start with this one from Dr. Felikovi. It's from 2005. And what he did, he has a group A where stimulation is maintained steady, and a group B where when the 6th follicle has reached 12 millimeter, they discontinuate the FSH-HMG product and they replace it with the HCG. And this slide only to demonstrate that when you do that, we can see the number of, let's say, small follicle is decreasing compared to the non-stimulated follicles. But at the end, we have a kind of a similar number of large preovulatory follicle that are available for stimulation. So it does what it's supposed to do. It decreases the small one and does not decrease the large one that we need for ovulation. If we compare the results in this graph, we can see there is not much difference, significant difference. Of course, the number of duration of FSH, or the amount of FSH, is lower because here we replace in group B with HCG. But the only difference was the higher fertilization, and we can see the numbers are too low. There's maybe advantages here, but I mean that have to be replicated quite heavily so people can really have more data, more number, more evidence that this could be a positive outcome. But it isn't, certainly it doesn't look bad. A second one from DeVoy, a bit later in 2009, and this is kind of a similar approach. And the conclusion is that the FSH, in this pilot trial, this FSH replacement by low HCG does not have any detrimental effect, but indeed will reduce the number of doses that's going to be used. So it's kind of a similar concept where they start with FSH, and when they start the antagonist, they start replacing FSH with LH starting at day 6, and then the trigger. And doing that does not, again, make a huge difference in terms of a number of pregnancy, but it's, even if it's not significant, it's not detrimental. I mean, there's sometimes more live birth death and more live birth ongoing pregnancy per embryo transfer. So those two studies are quite supportive of using a transition from FSH to LH, and I'm surprised that very few people have, explore more, let's say, more importantly or more largely this concept, where in animals we have shown that this is very, very useful to increase the quality of oocytes produced using that FSH decrease period to kind of synchronize the follicle before triggering ovulation. Other consideration, I mean, there's different ways to approach that. Doctor can use the pill to synchronize a new way with more homogeneity, because you want to have as many large follicle growing at the same time, because your recruitment period is going to be shorter. You can reduce FSH to 0 once the LH support has begun, but people are kind of afraid that the estradiol might drop and then could create a uterine delay. So there's again an investigation to how low the reducing FSH should be to be in the right mimicking of the natural cycle. Again, using recombinant LH or HCG, it's according to the half-life. I mean, recombinant LH has a much shorter half-life, so if you want to maintain follicular growth through LH support, it's better to have more frequent injection, of course, of LH compared to HCG, and LH has a not so strong HCG effect for luteinization of the granulosa cells. And the time of trigger has to be adjusted for the number of follicles that are present in each patient. So there could be not necessarily a unique recipe for each patient, but you follow patients until they have the right number of follicles, and then you synchronize the differentiation of the follicle by lowering LH, and then when you have 4 days of that, that's sufficient, and then you can trigger ovulation with HCG or the agonist. So what I've tried to explain or to challenge you with you today is the natural physiology demonstrate that FSH and LH have roles in sequence more than in combination during the natural ovarian cycle. The auricular stimulation does not mimic the natural sequence. We're giving a kind of wrong signal somewhere to the ovary that the ovary is sensitive to and might react by decreasing oocytes quality in response to that. Physiological animal studies in animal has shown that the potential benefit of doing that and has improved the blastocyst rate from 30 to 60% by using and adapting the FSH decrease to increase oocytes quality. So I'm asking the question in closing, now is the time to listen to the natural cycle physiology. So I hope that my talk will generate a lot of questions and comments, because this is kind of going back 40 years, looking at physiology and try to reinvent stimulation based on what nature is telling us. And this is not something we do every day, going back that far, but I think it's worth it to re-explore the natural physiology to improve a technique that should do better than it's doing now, and especially after 40 years. So I thank you, and I'm ready to take any comments or question for this presentation.